Hey guys, welcome to week 2 of Earth Science at school. We are going to dive into an actual unit now. Hey guys, welcome to week 2 of school. We're going to dive into our first real unit, the universe. So these next couple units we're going to be talking about space and where our Earth lies within it. And today we're just going to talk about galaxies. All right, so there's 3 different types we're going to talk about. You guys should be able to identify and explain them. So first off, what is a galaxy? A galaxy is an area composed of suns, stars, planets, and other interstellar matter that we'll talk about later. They grow by crashing into each other and merging and building up. We live in what's called the Milky Way galaxy. We are currently absorbing 2 tiny galaxies that we know of. By tiny, they're bigger than our solar system, but they're still tiny. We're called the Milky Way because it's a dim, milky-looking blotch in the sky from our viewpoint. If you've ever seen the pictures of the sky at night, some professional photography, you can see there's one part of the sky that's just so much brighter than the rest, and that's part of our Milky Way. Astronomers classify galaxies into 3 major categories. So we're going to talk about spiral, elliptical, and irregular. So spiral galaxies are a thin, flat disk shape, and flat is relative when it comes to space. It's still much larger than we can figure, but it's much wider than it is taller. That disk consists of a large population of young, hot stars and dust-laden clouds that orbit around a center bulge, like you can see in that picture. It consists of stars, gas, and dust, and that bulge is a concentration of stars in the center. It tends to be the older stars. We know that based off of color, and we'll get to that later too. All right, the spiral arms that extend from the center bulge out into the galactic disk are where you can find several different solar systems like ours. You also get a halo that surrounds the arms. You can still see the specific arms spiraling out like you can right in here, but notice it looks a little dusty or a little blurry. That's just gases, older stars, and dark matter. About 2/3 of these galaxies have a band of stars extending out from the bulge that merges with the spiral arms, called barred spiral galaxies. And then it's estimated that over 70% of the largest galaxies in the universe are spiral. And they're all getting that spiral shape from the gravity of the center stars pulling it in. Alright, elliptical galaxies. When we talk elliptical, we mean a sphere-shaped, not quite circular, but round. They also have a center bulge, like you can see in this picture. They have that dusty-looking halo. It is not flat and disc-shaped, like we saw in the last picture. It's composed mostly of older, low-mass stars. We'll talk about red dwarfs later on, but they tend to be older, smaller stars. There's minimal amounts of dust and cool gases, and because of that, there's a low rate of star formation because there's not a whole lot of stuff to collide into each other and build up, like you would with Legos. And then typically the largest and the smallest galaxies are elliptical galaxies. So we have dwarf galaxies, like the 2 that the Milky Way is absorbing. They're called Magellanic clouds, like Magellan that traveled the oceans and circumnavigated the globe. They're the hardest to detect because they're generally very dim and tiny, and they're so far away, it's not like trying to look at something down the street. The largest galaxies are 10 times larger than the Milky Way galaxy, and they merge from several smaller galaxies coming together, colliding and building. Irregular galaxies is the last category. This is about 25% of our known galaxies. There's absolutely no symmetry at all, so no mirror image of itself. Mostly spiral and elliptical are destroyed by gravity of a nearby galaxy. That will stretch it out in some weird ways and give you some of your irregular galaxies. The Milky Way's large and small Magellanic galaxies are irregular due to that gravitation pull. So they once were smaller elliptical ones. Now that they're getting sucked into the Milky Way, now they're becoming irregular. Galaxy clusters. So galaxies are often found together, kind of grouped. So we call them a galaxy cluster. Our local group, that includes the Milky Way galaxy, has more than 40 other galaxies that we know of that are actually relatively close to us. Superclusters are much larger clusters of galaxies, and it's estimated to be over 10 million different superclusters. So we're not even a big cluster of galaxies, and they estimate over 10 million superclusters of galaxies. So there's a lot of stars out there. All right, galactic collisions. I think some of the coolest parts. So within galaxy clusters, galaxies will actually frequently interact with one another through gravity. When I say frequently, this does happen over millions of years. Keep that in mind. Or even, yeah, millions of years is most common. An example is a large galaxy engulfs a dwarf galaxy and they become one, right? Like we're absorbing the Magellanic galaxies. Another example is two similar sized galaxies pass through each other without ever merging, and when they're too spaced out to collide, but the interstellar matter, that dust and gas, things like that, may still react and create a star. Another one that's a little rare is two large galaxies collide and become one single extremely large galaxy. It is estimated in 2 to 4 billion years, so about the time our sun will be winding down, there's a 50% chance that the Milky Way and the Andromeda galaxies will collide and merge. They are considered most likely to be this second example, where they just kind of pass through each other without merging, or actually merging and creating a super large galaxy. So here you have a video. So there are a few questions to answer in your note packet, and about the collisions or potential collisions between Milky Way and Andromeda. See you guys later.